Welcome to the Calculus A section. In this section, we'll be discussing maximum and minimum values. Now, buckle up because this is where calculus becomes very interesting or increasingly difficult. Pick your poison. So up until this point, we have either taken derivatives to find the rate of change at a given point or relate the rates of two different situations. But what if we could find the maximum or minimum value of a function using derivatives without the graph? So let's say we had the function here, f of x is equal to x cubed minus 3x squared plus 9x plus 4, okay? Now, if we were to take the derivative of this function, and we would get 3x squared minus 6x plus 9 plus 0, because this is a constant. Now, this is the derivative of the function. But if we were to set this function equal to 0, we would get what are called critical points. Now, critical points are the points on the graph where the function or the derivative of the function is equal to 0, also known as our maximum or minimum points. So we can set this equal to 0 and factor out a 3 and say x squared minus 2x plus 3. Divide the 3 over, so we have 0 equals x squared minus 2x plus 3, and then just do some difference of squares. Oh, we got the signs incorrect. Minus 3. So x is equal to -1 or 3. Now, we have our critical points, and we know that there's either a maximum or a minimum at these points. Now, in order to test this, we take the second derivative of our function, and knowing that our first derivative is 3x squared minus 6x plus 9, we take the second derivative and say 6x minus 6. Now, we plug in our critical points to our second derivative test, and if it is above 0 or greater than or equal to 0, our critical point is a maximum, a local maximum, and if it is below 0, our critical point is a minimum. So we can try this with f prime double prime of -1, and that is equal to -12, so that is a local minimum. And f double prime of 3 is equal to 18 minus 6, and that is a local max. Now, in order to find the y-coordinate of these maximums and minimums, we plug them back into our original function. So f of -1 is equal to -1 minus 3 minus 9 plus 4. So this is equal to -4. So these two cancel out. So we get -9. And f of 3 is equal to 27 minus 27 plus 27 plus 4. That is equal to 31. So we have at 331, we have a local max. And at -1, -9, we have a local minimum. And that is how you solve maximums and minimum values. Now, if you need more assistance or more insight on the concept, the website has a bunch of resources. I hope that helps.